believe the audience enjoyed it a lot. So moving on to the Q&A session. The first question we have in the chat box is, I couldn't get the species with carbocation that has zero electrophilicity. Would you please explain it in brief?
Well, this is, sorry, this is, so can I get,
Okay, so you want to share your screen?
yes, I wanted to go back.
Yes.
This is quite simple. Yeah, you see, I have here 29 nucleophilicity scales, and I want to put it on a basis. And so, just by definition, we have to fix one point. And I could have taken any of these electrophiles as the reference, and just for historic reason, we selected this as E equals 0. But this does not mean any absolute value. We just took this because at the time this was the slowest electrophile we were studying. This compare it to the situation in the Hammett equation. Hammett has defined the sigma value of hydrogen is 0. This is also arbitrary. And here also just this is arbitrarily selecting this as 0. It could have taken any other of these things. Important is just the relative reactivity. And then Hammett has defined dissociation constants of benzoic acids as rho equals 1. And we have selected here S equals 1 for this methyl pentene. But again, we could have taken any other reference slide. And this was just needed. These two definitions are needed for making the least squares analysis. So no special meaning in it. It is arbitrary. And as I was mentioning, this whole picture is only based on two effects. Measuring second-order rate constants, these two definitions, and the rest least squares analysis. Was this clear, or need extra information?
Most probably the person who asked this question will answer in the chat box if.
Okay.
Yeah. Moving to the next question. Thank you, Professor Mayr, for this response. Moving to the next question. Could you suggest a way to design or predict Ohm-Polong reactions utilizing your studies?
Yes, of course. I mean, Ohm-Polong, this would mean you make, well, let's take the easiest thing. For example, a carbonyl compound, we determine an electrophilicity parameter. And then if you make the heterocycle with the two sulfurs, and then this is a nucleophile, and you can then determine the nucleophilicity as I have derived. And so you can easily compare then the nucleophilicity and the electrophilicity. And I think this is a method which can be done very straightforwardly.
Okay, thank you. On the next question, is there an alternate equation which could correlate these parameters at high temperatures?
We have studied a temperature dependence of some of these reactions, but I think well, what you should keep in mind is when you have the fast reactions, they are mostly controlled by entropy, and you have a very small temperature coefficient. you cannot change the temperature easily, but the slow reactions they will be accelerated more by temperature increase than the fast reactions. So you have to do this individually for each of the reactions. So we cannot make a similar equation for another temperature.
Thank you. Moving to the next question. Have these reactions been studied for ring opening reactions of small strained ring systems?
Yes, they have been studied. These are Ophial has studied ring openings of epoxides, and but then this is a SN2 type reaction, and so you need an extra slope parameter like in SN2 type reactions.
Okay, thank you. The next question, how to find a balance between the stability and reactivity of the nucleophiles or the electrophiles?
I'm not sure whether I understood this question properly. I mean,
The question is
as
how to find.
as we just have this picture, I mean, these carbocation up to here they can easily be or up to here they can easily be handled as stable species, and then we have highly reactive species which are not so easily handled as stable species. And the same thing is with the nucleophiles. When you have when you do not have highly stabilized carbanions, you have to use certain techniques to handle them. If this question, if this maybe I have not properly understood the answer, please write me an email and I will try to answer this question in a more professional way.
Yeah, sure. Thank you. The next question. You have already tested a lot of nucleophiles, but less electrophiles. Are you planning to test very common electrophiles like alkyl halides or acid chlorides in the future?
Well, I would love to, but as you see from my CV, I'm retired, and so I do not have the possibility to study more systems. But certainly, more electrophiles should be studied to make this a more comprehensive picture. Dr. Ophial is continuing these studies, but his capacity is also limited, and so I think I hope that other people will jump into this field and continue this work.
Sure. Thank you so much for your response. Moving to the final question for the day. Is there any correlation between hardness and softness with the nucleophilic and electrophilic strength of the species?
Well, this is I just can refer to an essay which I published in Angewandte Chemie in about 10-15 years ago, showing that the hard and the title of this is A Farewell to the Hard and Soft Acid-Base Treatment of Ambident Reactivity. And so I think in this essay I have been showing that treating ambident reactivities of cyanide ion, of thiocyanate ion, of nitrite ion, this is all incorrectly predicted by the hard and soft acid-base problems. So please forget hard and soft for treating kinetics, and have a look at my review in Angewandte Chemie. If you can't find it, send me an email and I'll send you a copy of that.
Sure. Thank you so much, Professor Mayr, for this wonderful discussion, and hope the audience liked it a lot.